Hello everybody, welcome to our first distance learning lesson for our college algebra class. It's good to be back with everybody. You have the note packet that was uploaded onto our Google Classroom, and the first part of the notes we're going to talk about from there are on what linear systems are. So we have three different types of solutions for linear systems. The first type is when you have one single ordered pair answer, like 2, 3, or -7, 4, 9, something like that. This system is called consistent, and the equations are considered independent. So let's say got our point here, a line, and a line. And this is a solution. We're looking for the place where our lines cross, if they cross. So an example of what that might look like is 2x minus y is equal to 2, and x plus y is equal to -2. Parallel lines. So if we have parallel lines, remember parallel lines run in the same direction, have the same slope, but different y-intercepts. Parallel lines are called parallel because they're never going to cross. If our solution then is where do they cross, and these never do, this would have no solution. Because there's no solution, this is an inconsistent system, and the equations are still independent. Sample of those types of equations might be 3x plus 2y is equal to 3, and 3x plus 2y is equal to -4. You see that it's going to end up to have the same slope when we get y alone with the 2 and the 3, because they're both exactly the same in both equations, and the only thing that's different is the number on the other side of the equal sign. The last type of the solution is when I have two graphs that end up to be the same line. So I graph one, and then I graph the other. They end up looking like that. Again, we're looking for where our lines cross or where they touch. That's our solution. Well, these touch all the time. They touch everywhere. So they have an infinite number of solutions, or infinitely many. This system, because we do have a solution, is consistent, and the equations then are independent. So to start solving our systems, we're using the substitution method. A reminder that our first step in the substitution method is to start with solving one of your equations for x or y. It doesn't matter if you solve for x or for y when you're starting with the substitution, because you have to solve for both anyway. So whichever one it is that you pick, it won't matter. For me, I always like to look for an x or a y that is already by itself. Essentially, there's no number in front of it. It's not a negative, even though having a negative isn't that big of a deal. So in this first example, I'd probably pick that positive y. And in the second example, I'd probably pick this x. If you don't have something that has a single, just a 1 in front of it, then you're going to have to do a little bit more steps. But that's always my go-to to start with. So in this equation, the example on the left, I'm going to go ahead and get this y alone by adding x to the other side. So we have y is equal to 3 plus x. I'm plugging this equation in for that right there. That's the only thing that's changing when I solve this problem. So I keep the 3x plus 2 equals 11. All of that stays the same. I'm putting this in here, and I'm simplifying the problem and solving for x. So I'm going to distribute the 2, 3x plus 6, plus 2x is equal to 11. Combine those like terms. 3x plus 2x is 5x. Subtract 6. 5x is equal to 5. Divide by 5. And x is equal to 1. That's only the first part, though, of our answer. Remember, we have an ordered pair answer. Ordered pairs are two numbers with a comma and parentheses around it to show that one point on a graph where our lines will cross. Now that I know that x is 1, I can take either of these two equations, plug 1 in for x to get y. Now I'm going to pick this bottom one of y equals 3 plus x because y is already set by itself. So when I plug in 1 for x, it's a simple problem of just 3 plus 1 is 4. So the solution to that system is 1, 4. All right, for this second example, we had said we were going to try to get this x alone. So I'm going to add the 2y over. So that's x equals 1 plus 2y. That 1 plus 2y is going in right here for this x in the top equation. And again, that's the only thing that's going to change. So I keep the 4 minus 3y equals 14. And plug in that 1 plus 2y where the x was before. Simplify the problem and solve for y. 4 times 1 is 4. 4 times 2y is 8y. Like terms, 8y minus 3y is 5y. Subtract the 4 to the other side. 5y is equal to 10. Divide by 5. and we get y is equal to 2. So the first part of that solution, oops, and I just did it. Remember, that's y, not x. So that has to go in the second half of our ordered pair solution. Now I need to go back to our equations that are over here on the right side, and I did pick one of them to plug in y. Again, I'm probably going to use this bottom one because x is already alone. So I have 1 plus 2 times 2, because I'm plugging in the 2 we found for the y. 2 times 2 is 4, and 1 plus 4 is 5. So the solution to that system is 5, 2. That's it for today. Don't forget to take your ticket out before you finish today. It's due by 8 o'clock tonight. And then check out our office hours if you need any help. Thanks, everybody. Have a great day.